Hypothesis test for one population proportion. One proportion Z test. Purpose: to perform a hypothesis test for a population proportion P. Assumptions: 1. Simple random sample. 2. Both n p sub 0 and n parentheses 1 minus p sub 0 are 5 or greater. One proportion Z test. Step 1. The null hypothesis H sub 0 colon P equals P sub 0, and the alternative hypothesis is H sub A colon P does not equal P sub 0 for two-tailed test, or H sub A colon P is less than P sub 0 left-tailed test, or H sub A colon P greater than P sub 0 right-tailed test. Step 2. Decide on the significance level alpha. Step 3. Compute the value of the test statistic and denote that value Z sub 0. Z equals P hat minus P sub 0 all over the square root of P sub 0 parentheses 1 minus P sub 0 divided by n. One proportion Z test using critical values. Step 4. The critical values are plus or minus Z sub alpha divided by 2 for a two-tailed test, where the rejection region is to the left of negative Z sub alpha divided by 2 and to the right of positive Z sub alpha divided by 2. Or negative Z sub alpha left-tailed, where the rejection region is the area to the left of negative Z sub alpha. Or Z sub alpha right-tailed, where the rejection region is the area to the right of Z sub alpha. Use the standard normal distribution table to find the critical values. Step 5. If the value of the test statistic falls in the rejection region, reject H sub 0. Otherwise, do not reject H sub 0. Step 6. Interpret the results of the hypothesis test. One proportion Z test using p-value approach. Step 4. Use the standard normal distribution table to obtain the p-value. For a two-tailed test, the p-value is both to the left of negative absolute value Z sub 0 and the area to the right of positive absolute value Z sub 0. For a left-tailed test, the p-value is the area to the left of Z sub 0. And for a right-tailed test, the p-value is the area to the right of Z sub 0. Step 5. If P is less than or equal to alpha, reject H sub 0. Otherwise, do not reject H sub 0. Step 6. Interpret the results of the hypothesis test. Example using critical values. The number of successes and the sample size for a simple random sample from a population are given below. X equals 6, n equals 30, H sub 0 is P equals 0.3, H sub A is P does not equal 0.3, alpha equals 0.05. Determine the sample proportion. P hat equals X divided by N. My X is 6, my N is 30, 6 divided by 30 is 0.2. Continuing, is it appropriate to use the one proportion Z test? In order to use the one proportion Z test, both n times P sub 0 and n times 1 minus P sub 0 are 5 or greater. N times P sub 0 is 30 times 0.3, which is 9. N times 1 minus P sub 0 equals 30 times 1 minus 0.3, which is 21. Yes, it is appropriate. Continuing, use the one proportion z-test to perform the specified hypothesis test. Step 1, we need to decide if we have a left-tailed, right-tailed, or two-tailed test. Since for h sub a, p does not equal 0.3, I have a two-tailed test. Step 2, decide on the significance level alpha. In the original problem, they told us that alpha was 0.05. Continuing, step 3. Compute the value of the test statistic and denote that value z sub 0. Z equals p hat minus p sub 0 divided by the square root of p sub 0 times 1 minus p sub 0 divided by n. Substituting, I have 0.2 minus 0.3 divided by the square root of 0.3 parentheses 1 minus 0.3 divided by 30. Going to our calculator, I want my numerator in parentheses, open parentheses, 0.2 minus 0.3, close parenthesis for my numerator, divided by, I don't need parentheses since my denominator is under the square root, 0.3, open parenthesis, 1 minus 0.3, close parenthesis, divided by 30, close parenthesis, or arrow to your right. I could have also used times 0.7 instead of 1 minus 0.3. Enter. And I have negative 1.195, which rounds to negative 1.20. The test statistic is z equals negative 1.20. Step 4, identify the critical value. We're looking for plus or minus z sub alpha divided by 2. Since alpha is 0.05, if I divide that in half, I have plus or minus z sub 0.025. Going to our table and find our value for z, which equals plus or minus 1.960. The critical value is plus or minus z sub alpha divided by 2 equals plus or minus 1.960. Moving to step 5, if the value of the test statistic falls in the rejection region, reject h sub 0. Otherwise, do not reject h sub 0. So we've plotted our test statistic and critical values on our picture, and z equals negative 1.2 falls in the do not reject h sub 0 region. Do not reject h sub 0, the null hypothesis. Step 6, interpret the results of the hypothesis test. The data do not provide sufficient evidence to conclude that p does not equal 0.3. Example using critical values. According to a survey of 750 web users from Generation Y, 405 reported using the internet to download music. At the 10% significance level, do the data provide sufficient evidence to conclude that a majority of Generation Y web users use the internet to download music? Determine the sample proportion. We need to know X and N. X is 405. N is our sample size of 750. To find p hat, I want x divided by n. 405 divided by 750 is 0.54. Continue with our example. We need to note that the assumption is that the proportion of Generation Y web users who use the internet to download music is equal to the proportion that do not. So P sub 0 is going to equal 0.5. Since 0.5 plus 0.5 is 1, which is 100%. Now we need to decide if both n times P sub 0 and n times 1 minus P sub 0 are 5 or greater. We know so far that x is 405, n is 750, P sub 0 is 0.5, and alpha is 0.1. Finding n times P sub 0, 750 times 0.5 is 375. Next, we want to find n times 1 minus P sub 0. So 750 times 1 minus 0.5 is also 375. Yes, both n P sub 0 and n times 1 minus P sub 0 are 5 or greater. Continuing, what are the hypotheses for the 1 proportion z test? Step 1, I want to find h sub 0 and h sub a. H sub 0 is p equals 0.5. Since we want to prove that a majority of Generation Y web users use the internet to download music, we want h sub a to be p is greater than 0.5. Now we have to decide if we're dealing with a left-tailed, right-tailed, or two-tailed test. Since h sub a is greater than, it's a right-tailed test. Step 2, decide on the significance level alpha. We were told in the original problem that alpha is 0.1. What is the test statistic? Step 3, compute the value of the test statistic and denote that value z sub 0. Our formula for z is p hat minus p sub 0 all over p sub 0 parentheses 1 minus p sub 0 divided by n. Substituting, we have 0.54 minus 0.5 all over square root 0.5 parentheses 1 minus 0.5 divided by 750. Calculating, we want our numerator in parentheses, so open parenthesis, 0.54 minus 0.5, close parentheses, divided by square root 0.5 parenthesis 1 minus 0.5 close parenthesis, or you could have simply put times 0.5 divided by 750. Arrow right or close your parenthesis, enter, and I get my z value, which is 2.19. The test statistic is z equals 2.19. Now I am ready to use critical values. So step 4, I have to identify the critical value. Since it is a left-tailed test, z sub alpha is going to equal z sub 0.10. Going to our table, I find the z-score for c sub 0.1, and it is 1.282. The critical value is z sub alpha 1.282. Step 5, if the value of the test statistic falls in the rejection region, reject h sub 0. Otherwise, do not reject h sub 0. So plotting the test statistic and the critical value on our graph, I can see that z equals 2.19 is to the right of my critical value of 1.282. That means it is in the rejection region. Reject h sub 0, the null hypothesis. Step 6. Interpret the results of the hypothesis test. The data do not provide sufficient evidence to conclude that a majority of Generation Y web users use the Internet to download music. Example using p-values. In a recent poll, 1,009 randomly selected adults were asked whether they approve of labor unions. 59% said yes. In 1936, about 61% of adults approved labor unions. At the 10% significance level, do the data provide sufficient evidence to conclude that the percentage of adults who approve labor unions had decreased since 1936? Use the 1 proportion z-test to perform the appropriate hypothesis test after checking the conditions for the procedure. So we need to know 4 things: n, p hat, p sub 0, and alpha. N is my sample size, which is 1,009. P hat equals 0.59 because that's the percentage from my most recent poll. P sub 0 is 0.61 because that's percentage from my previous poll. Alpha is 10%, 0.10. First, we have to decide if it's appropriate to use the 1 proportion z-test. Both n times p sub 0 and n parentheses 1 minus p sub 0 are 5 or greater. N times p sub 0 would be 1,009 times 0.61, and that gives us 615.49, which is greater than 5. Then we want to find n parentheses 1 minus p sub 0, which is 1,009 times 1 minus 0.61, which is 393.51, which is also greater than 5. So yes, it's appropriate. What are the hypotheses for the 1 proportion z-test? Step 1 is to find h sub 0 and h sub a. As always, h sub 0 is p equals 0.61. Now we have to find h sub a. Since we need to prove that there was a decrease since 1936, h sub a is p is less than 0.61. Looking at h sub a, we need to decide if we have a left-tailed, right-tailed, or two-tailed test. Since it is less than, it is left-tailed. Our p-value is going to be the area to the left of z sub 0. Step 2, decide on the significance level alpha. As given in the original problem, alpha is 0.10. Step 3, compute the value of the test statistic and denote that value z sub 0. Our z formula is p hat minus p sub 0 all over the square root of p sub 0 parentheses 1 minus p sub 0 divided by n. Substituting 0.59 minus 0.61 all over square root 0.61 parentheses 1 minus 0.61 divided by 1,009. Calculating. I want parentheses around my numerator. Parenthesis 0.59 minus 0.61, close parenthesis, divided by square root 0.61, parenthesis 1 minus 0.61, divided by 1,009. I can either close my parenthesis or arrow right. Enter. Rounding to 2 decimal places. Z equals negative 1.30. The test statistic is z equals negative 1.30. Step 4. Use the standard normal distribution table to obtain the p-value. Since z is negative 1.30, I want to go to my table. Negative 1.30 is 0.0968. So p equals 0.0968. Step 5, if p is less than or equal to alpha, reject h sub 0. Otherwise, do not reject h sub 0. We want to compare p to alpha. 0.0968 is less than or equal to 0.1. The p-value is less than 0.1. Reject h sub 0, the null hypothesis. Step 6. Interpret the results of the hypothesis test. The data do not provide sufficient evidence to conclude that the percentage of adults who approve of labor unions has decreased since 1936. To recap, hypothesis test for one population proportion. One proportion Z test. The main difference is that to find our test statistic, we are using Z equals p hat minus p sub 0 all over the square root of p sub 0 times 1 minus p sub 0 divided by n.